Here in the Tucson Mountains, just west of the city of Tucson, we can find evidence of giant volcanoes. In fact, the rocks here are part of a caldera that was formed during the early Tertiary period as the Rockies were being formed and as the Pacific plate was riding down and melting beneath this part of the North American plate. The magmas that were bubbling up under Tucson at the time were extremely sticky, silica-rich magmas, and so they erupted explosively. We have rhyolites and we have ash flows here that would have been similar to, say, Yellowstone's volcano eruption. And that whole volcano erupted so broadly that eventually the magma chamber emptied and the whole thing collapsed, forming the caldera, the remnants of which we see in the rocks today. So for 600 or 700 million years, nothing really happened in this part of Arizona. It was a flat piece of igneous rock that was eroding over time. And then sometime around 150 million years ago, at the beginning of the Mesozoic period, an ocean came in and flooded this part of Arizona. And we got sandstones and other sedimentary rocks that were the precursors to this rock here. This is a schist, and there's quartzites and other metamorphic rocks in this part of Arizona that occurred because of the sedimentary rocks in this shallow sea getting changed and metamorphosed into other types of rocks. Here in the Tucson Mountains, we can not only see the volcanic rocks from the caldera and the eruptions, but we can see the rocks laid down in this shallow sea about 150 million years ago. So the rock that I'm sitting on actually happens to be a piece of volcanic rock that's rolled down the hill. And if you look closely at this is rhyolite, so this is similar in composition to granite, but it's very fine grained. Except if you look closely, you can see crystals inside of it. These are called phenocrysts. We call this a porphyritic rhyolite because it contains both fine crystals you can't see and these large crystals that you can. And what that tells geologists is that magma started to cool and crystallize deep down a little bit before it erupted. And so it brought these bigger crystals up to the surface, and when it hit the surface, it cooled quickly, and all the mass of magma around those crystals froze into very tiny crystals. So it tells us a little bit about how the magma was moving and crystallizing before the eruption. So this is an awesome place to see what's called the Tucson Mountain Chaos. Literally, this is called the Tucson Mountain Chaos. And this is a rock that is a volcanic rock that was created when this massive explosion, this volcano eruption occurred. And it ripped up all of the pre-existing rocks. And there were metamorphic rocks, there were sedimentary rocks, there were igneous rocks. They all got torn up and redeposited in this ash flow. And now you can see all these different clasts, or these pieces of that older rock, all kind of sort of stuck within this breccia, or conglomerate, if you will. And so it's a really cool place just to see and think about the violence of an explosive eruption like the caldera that we're standing in, and the force that would have been to rip all these rocks up and toss them out and bake them all into a brand new rock, probably within minutes. Let's go check out the Arizona Sonoran Desert Museum. Come on. So this is a great place here at the Sonora Museum where you can see these valley fill deposits that literally tens of thousands of feet of these fill these giant holes between these mountains. So if you see a mountain across the valley and another mountain, what's in between are these really deep valleys filled with layer upon layer of this. There's probably over 10,000 feet of this under my feet right now. So astounding, but it's all stuff that's eroded off the mountains over time. Ed Schiffler first came to the Tombstone area in the late 1800s, or in 1878, he found signs of this ore, this white material, and this is actually the ore that silver was discovered in. And it didn't take long before prospectors came to Tombstone from all over the country. The reason why the silver is here in Tombstone is there were porous sedimentary rocks that had been eroded into this sort of flat hillside that Tombstone's built on top of. The silver comes from fluids, mineral-rich fluids that move through these sedimentary rocks, literally below the town of Tombstone. All of those sort of gray hills around Tombstone are full of veins of this silver ore. And there are other things in there, copper, manganese, other things, but it was the silver that drew prospectors out here. Unfortunately, about 10, 12 years after this was discovered, before the town of Tombstone could really take off, the mine started to flood. And so as the water level rose, it became harder and harder to mine the silver until finally the mines were abandoned. So we've got a couple of mining carts here full of limestone and this sort of silty limestone, and this is called the Bisbee Formation. The Bisbee runs right through Tombstone on the way down to the town of Bisbee, where it's mined there as well. And this was laid down in the late Cretaceous time in a vast sea that covered this part of Arizona. It's shallow water. But the limestone later on in the Laramide, which was a period of volcanic activity that occurred late in the Cretaceous into the Tertiary period, or the Miocene, that actually created a lot of fluids, hot fluids, mineralized fluids that flowed through those limestones and deposited minerals like galena that had silver in them. And that is what the miners were after here. These giant chunks of limestone could be dissolved and the metal extracted from the minerals within the rock. The mining continued here until they mined all the way down and hit the water table. And that was a problem because the mines started to flood. There were several attempts made to pump the water out of the mines, but eventually they just couldn't keep up with the water. And by 1890, the mining around Tombstone had pretty well started to die out. Tombstone Courthouse is a great place to see some exhibits showing mining equipment and informational display on how silver was actually extracted from the limestone here. Saguaros are the kings of the cactus world, and they tower above the desert just east of Tucson. These amazing cactuses are very unique in the cactus world because of their size and height. When they're very young, they actually grow pretty slowly, only about an inch in the first 7 or 8 years, and then steadily after that, and reach their maximum height of about 40 or 50 feet tall, somewhere around 150 years old. The highest known cactus out here is somewhere around 70, 75 feet tall. And some of them have amazing branched arms, but they don't start to get those until 70 or 80 years old.